Hello students, welcome to another episode of Mr. Lim Explains. Okay, so today we are going to look at Canberra Secondary School 2019 SA1, okay, the 4 NTech paper, okay, paper 2. Okay, so without further ado, let's go on to the first question. Okay, for the first question, okay, you notice that this is a distance time graph. Okay, the question says it's a distance time graph, okay, of a object over a period of 35 seconds. So the object will travel from 0 to 10 seconds upwards in this manner to 6 meters. Then after that, it remains at 6 meters for 20 seconds, and after that you come down to 0 meters in 5 seconds. Okay, so based on this, if you look at the question, okay, describe the motion of the object during the AB and BC, you notice that I've written down in a certain way. So in this first case, when we talk about AB is actually in a straight line here. Okay, so in terms of graph, it looks like it is a straight line. Okay, but in the meaning of it, it actually means that it's actually traveling at a constant speed. Why? Because you can see that the distance is changing at the same rate compared to the time. Okay, so for every 1 unit change in time, the distance change at the same rate. Okay, for BC, this one, you notice that the object is staying at 6 meters. Okay, so you know, then once you understand that it stays at 6 meters, it means that it's actually stationary. Okay, for part B, okay, you notice that the question asks you to calculate the speed of the object between AB. Okay, so we know the speed is distance divided by time, so this one is very straightforward. Calculation wise, you should get 0.60 meters per second. Make sure your answer here and here is the same. Okay, so there is a error here in the question. This one should be meters per second and not meters. Okay, part C. Okay, we want to find the average speed. Okay, average speed is total distance divided by total time. So you need to be very careful with this aspect. Okay, so the total distance in this question, you notice that it travel from 0 to 6 meters. After that, from C back to D is another 6 meters. So total it has traveled 12 meters. Okay, 6 plus 6 is 12 meters. Okay, but the average speed, when we talk about average speed, is total distance divided by total time. So I need to take the 12 meters divided by 35 seconds in total, so total time. So that's why my calculation wise, I'll get 0.3428 something. Okay, always convert your final answer into 2 or 3 SF. So in this case, I would like to convert into 3 SF. That's why my answer is 0.343 meters per second. Okay. Next up, second question. Okay, this one is about conservation of energy. Part A here, okay, it requires you to state the conservation of energy. Okay, principle of conservation of energy. So for principle of conservation of energy, it has two parts. The first part will say that energy cannot be created or destroyed. Okay, the second part actually will be the energy that we talk about here can only be transformed or transferred from one form to another. So only with these two parts, then you can get your 1 mark. Okay, so be very careful here. Part B. Part B, you notice that A is the highest, for go down to B and then go up to C again. Okay, so when we look at this progression, right, you notice that the starting energy here at the highest point is actually gravitational potential energy. Okay, this boy, as it moves downwards, this gravitational potential energy will be reduced. Okay, and when it reduces, the boy will actually travel faster. Okay, so kinetic energy will be the energy that is converted to. So B is kinetic energy. B has kinetic energy, but no gravitational potential energy because at the lowest is at its lowest point. Okay, so when you move up to C, okay, you gain some gravitational potential energy again. So kinetic energy to gravitational potential energy. Okay, so part C, part 1, highest gravitational potential energy will be at the highest point, meaning A in this case. So you know why? Because if you look at just look at the buttocks of the child itself for the best gauge, you notice that the buttock of the child is actually very high. Okay, so this one will give us A already. Okay, kinetic energy wise, the highest kinetic energy is actually at its lowest point. Okay, coming back to conservation of energy in part D again. Okay, you actually have to start off from the lowest part here. Okay, part 1, part 2, part 3. That's why it's phrased in this manner. Okay, now when the ball leaves the buoy, okay, is traveling at kinetic energy of 1000 joules. Okay, but at the lowest point, we will say that the gravitational potential energy is 0 joules. Okay, so take note that the total energy here is 1000 joules. So in the conservation of energy question, this total energy will be the same for all three segments. Okay, so having that understanding in mind, okay, since I know the total energy is 1000 joules and the gravitational potential energy is 500 joules, then the kinetic energy at this point must be 500 joules, because these two add together will give you the total energy. Okay, last but not least, at the highest point, okay, we know that at the highest point it will stop momentarily. So when it stop momentarily, the kinetic energy will be 0 joules. Okay, so if the kinetic energy is at 0 joules, then the gravitational potential energy has to be at 1000 joules. Okay, so why again? Because total energy is 1000 joules. So this one is a tricky one, because the understanding is at the highest point is momentarily stationary. Okay, so please keep this in mind. Okay, at the highest point. Okay, let's move on to the next question. Okay, for the next question, down here, part A asks you to find the amplitude and wavelength. Okay, amplitude is always from the rest position to the highest point, or the rest position to the lowest point. Okay, wavelength, on the other hand, is there are three ways to see it: from crest to crest, trough to trough, okay, or rest point to the third rest point. Okay, 1, 2, 3. Okay, so basically the general idea to see one wavelength is you must see a complete crest and a complete trough. Okay, so part B, you are asked to calculate the wavelength. Okay, so the wavelength is actually not really that obvious. Okay, but if you look at the question here in the graph, okay, you notice that there is 1, 2 and a half. Okay, I repeat again, 1, 2 and a half complete waves. Okay, and these 2.5 complete waves will cover 6 meters. Okay, so what does this tell us? Okay, this tells us that the 2.5 waves actually will cover 6 meters. So from this, I can actually do a calculation to get the one wave. Okay, so one wave will be 6 divided by 2.5. I'll get 2.4 meters. Okay, part C. What is meant by the frequency of a wave? Okay, the frequency of the wave, this one is a definition. Okay, so try to remember some of the definitions like this. This is quite a common question. Okay, so the frequency of waves is the number of complete waves passing through a point in 1 second. Okay, part D. Okay, part D is about the users. There are many users, so I'll mention some along the way as well. Okay, for infrared, you can say that it's used in the remote control to change the channel of TV. You can even say used in burglar alarms to detect motion. Okay, part 2, ultraviolet radiation. Okay, for ultraviolet radiation, there are a few uses. You can say you can use it for sunbaths to do sun tanning, or do sterilization, or detect forgery. Okay, so there are a few along the way. Okay, as well as the application is logical. Okay, last one, gamma rays. Gamma rays, generally we talk about gamma rays in two forms. One is to sterilize, okay, sterilization again to kill germs and all that. Okay, the other one is to use a gamma knife, okay, for surgery to kill cancer cells. Okay. Okay, for question 4, part A, if you see this setup, you notice that this meter is connected in series, this meter is connected in parallel. Okay, so a meter that connects in series has to be an ammeter. Okay, a meter that connects in parallel is a voltmeter. Okay, so there is a picture here, a resistor with an arrow is actually a variable resistor. Another name for variable resistor, okay, is a rheostat. Okay, so you can use either of these two names. Okay. Okay, for this next question, question 5, I think. Okay, you are asked to plot the graph. I wonder where my question 5 went. Yeah, okay, you're asked to plot the graph. Please go and plot it. Okay, make sure your axis and your these are current actually is correct. Okay, then from there, based on this question, okay, you should be able to get your answer. Okay, so with reference to that, okay, let me just flash you the answer very quickly. Okay, from the answer scheme. Okay, for this question is quite straightforward. You notice that only one of the points, after you plotted everything correctly, okay, only one of the points is off. Okay, so using that will be the answer for part B here. Part C here, sorry. Oh, they also didn't give. So the recommended answer down here will be 0.4. Okay, so you just check accordingly. Okay, question 5. Okay, question 5 is quite straightforward for the first part. Okay, part A, calculate the percentage daily value if on a 2500 calorie diet. Okay, so don't be tricked by this, because down here they already give you a 2000 calorie and 2500 here, but all these question here, the whole thing here is actually based on a 2000 calorie diet. Okay, so they actually wants you to recalculate the percentage daily value. Yeah. Okay, so for the 2500 calorie diet, if you calculate correctly, you are asked for fat. So if you look at the beef burger, the fat content here is 27 grams. Okay, so 27 divided by 80 grams times 100%, you actually get 33.75%. Okay, but percentage daily value is always a whole number, so please round off to the nearest whole number, which is 34%. Okay, state which burger should an obese person choose. Okay, explain your answer. So we know that obese person needs to avoid fats in general. Okay, so based on that, if you look at the content here, fats here for the beef burger is 27 grams, for the chicken burger is actually 9 grams. Okay, so that's why you should choose the chicken burger. Okay, another way to look at it is because the obese person, basically they have eaten too much, they have taken in too much calories, and therefore they need to reduce the amount of calories that they take in. So talking about that, okay, if you look at the energy level, the 340 grams 340 calories for the burger, beef burger, and 200 calories for the chicken burger, in comparison of these two, you definitely have to choose chicken burger as the answer. Okay, let's move on. Okay, question 6 is a very straightforward question. This one shows a transformer. So the core of the transformer is always made of iron, because it is temporary. It can be turned into a temporary magnet. Okay, so it can so-called change its magnetism, lose its magnetism, gain its magnetism very easily. Okay, part B. Explain what type of transformer is this. So based on this, you notice that the secondary coil is 50 turns, the primary coil there are 10 turns. Okay, so the step-up this is actually a step-up transformer. Why? Because there are more coils, or there are more turns. Okay, either you use the word turns or coils in the secondary coil than in the primary coil. Okay, part C, when I was doing it, I faced a little bit of difficulty, because I don't really know what they are trying to ask, but my guess was actually quite on the dot, on the spot. Okay, so basically they're asking you how much electrical energy does a battery contain compared to a power station. Okay, so we know that the battery is a cell, or battery is actually very small. It only contains 12 volts. Okay, at the same time, it doesn't last very long, so it contains a small amount of electrical energy. Okay, but power stations, on the other hand, will contain large amounts of energy, because they are constantly producing a lot of electrical energy that will supply to a whole section of a country. Okay, so you have to take note of that. Okay, the size wise, of course, batteries is very small, very portable. Okay, so it's actually small. The emphasis should be small. Okay, power station, no need to say, power station is very fixed. Okay, so the emphasis is actually large. Okay, question 7. Identify the following parts. F is actually the stomach if you look at it very carefully. Okay, and D is the small intestine. Okay, so looking at the picture, the diagram here, okay, let's identify the rest of parts very quickly. Okay, A is actually the mouth. Okay, B is the gullet, or you can use the word esophagus. Okay, C is the liver. Okay, how I know it's a liver? There are two ways. First, you identify the stomach. Okay, if the stomach is over here, then the other part here, which is quite large, also should be the liver. Okay, the one that looks like a leaf is the pancreas. Okay, then look at these wiggly things. The wiggly things is the small intestine. Okay, small intestine is one of the longest organ in our body. Okay, then H is the large intestine. Okay, and E here is actually the rectum. Okay, how do we know whether it's a rectum or anus? Look at the place that you point. If it points all the way at the end here, then this is a anus. Okay, but if it points this storage area here, then it should be a rectum. Okay, so having said that, identify the organs A to H that are responsible for digestion of proteins. Okay, so if we talk about digestion of proteins, there are only two places that digest proteins. First one would be, of course, the stomach. Okay, stomach digests protein. The second place where you digest protein would be actually the small intestine. So the small intestine has or will digest 3 different types of nutrients. Okay, your carbohydrates, proteins, and of course your fats. Okay, 3 things: carbohydrates, proteins, and fats. Okay, so that's why answer is F and D. Okay, part C here. The problem that the medical condition will be constipation actually, because of the lack of dietary fiber inside, so therefore the feces does not move along the large intestine very easily. Okay. Okay, question 8, fill in the blanks. Very straightforward. First one, plants make their own food through the process of photosynthesis. Make sure your spelling is correct. Okay, light energy is absorbed by chlorophyll. Okay, carbon dioxide is required along from the air as well as water so that they can produce sugar. Sugar will be changed into starch. Okay. Okay, down here I wrote wrongly. Okay, what is this? Sorry, there's an error in my answer. Let me refer to my answer. Question 9A, say the health level of the patients. For patient A is actually unhealthy. Okay, why is it unhealthy? Basically, if you look at the person, he's actually sick. Okay, so because he's tired, sleepy, and has some runny nose, so he's actually sick. Okay, so that's why he is unhealthy. Okay, but for person B at that moment in time, he's actually quite healthy because there are no complaints. Okay, so no sickness. Okay, and person C. Okay, person C is still considered quite healthy. Okay, why do I consider him quite healthy? If you look at the pulse rate, it's actually not too bad. The body temperature still remains at 37.8, which is slightly higher than a normal person. Okay, but doesn't really mean it's a fever yet. Okay, because the normal human's temperature is about 37.5 degrees Celsius, so it's not really feverish yet. Okay, so that's why I can't conclude whether he's sick or not. Okay, so therefore I have to say that he's healthy. Okay, next one, now here. Okay, recommended answer is actually this one is fit. Person A, patient A is actually considered fit. Okay, patient B is unfit, patient C is unfit. Okay, so how do we know about all these? So we look at for patient A, you look at the pulse rate. Okay, so pulse rate will give you a clue that this person, the heartbeat is actually quite slow. Okay, so it's not that bad in terms of health, in terms of fitness, so he should be quite fit. Okay, the fitter the person, the slower the heart will beat, but of course there's a lower limit of how much. Okay, so you have to be very careful there. For patient B, okay, patient B is unfit because of the high blood pressure. Okay, and patient C, okay, is unfit because if you look at the pulse rate, is actually quite high. Okay, for a normal person, so hence he should be unfit. Okay. So C is worried about osteoporosis. So osteoporosis is actually the lack of calcium in the bones, so making the bones very brittle. Okay, so that's the medical problem. Okay, so in order to prevent osteoporosis, when we talk about bones, you need to take in food with high vitamin D and calcium, basically. Okay, so that's the recommended answer. Okay. Question 10A. 10A, if you look at the optimum temperature of this enzyme, sorry. Okay, if you look at the optimum temperature of this enzyme, you notice that it's actually 40 degrees Celsius. How do I know? I'll take the ruler, place it here perpendicularly to the axis and find the highest point. Okay, at the highest point, if you draw it down, you should match to 40 degrees Celsius. Okay, next one, explain why the rate of reaction of point X is very low. So for this one, it's actually at this point here. Okay, why is it very low? If you look at this graph, you can actually interpret that it's actually because the temperature is low here. Okay, and this enzyme seems to be dependent on the temperature. At higher temperature, at 40 degrees Celsius, it works fine. Okay, but at lower temperature, it doesn't. Okay, so at the lower end, okay, the enzyme is actually inactive, okay, at low temperatures. Okay, so you must mention the word low temperature here. Okay, and you must mention the word inactive. Okay, be very careful whether you use inactive or destroyed. Okay, so in front here, the front part we will say inactive. Okay, before the optimum temperature. After the optimum temperature, we will usually say destroyed or degraded. Okay, we'll use these two words instead. Okay. Part B. Why can't chicken flesh be digested at the mouth, at the saliva? Okay, because basically the saliva does not have the enzyme to do the job. Okay, so the saliva in the enzyme in the saliva can only digest starch actually. Okay, so what is you see I have a full length of answer here. So which part do I need? I need the word no. I need the last part, enzyme can required to digest protein is not in the saliva. Okay, so this one will be a clearer answer. So you do not actually need the center portion here. Okay, question 11. Okay, calculate the energy in kilowatt hours. Very straightforward. Okay, you just need to calculate the power times time. Okay, so I'll write down here, energy equals to power times time. Okay, but in this way, in this particular question, they already give you the clue on the units that they need to use is kilowatt hours. Okay, so your watts, your power, 1500 watts must be converted into kilowatts. Okay, so that's why I do the 1500 divided by 1000. Okay, the hours wise, you need to divide by 60 to get the number of hours. So 120 minutes is actually 2 hours. So if you do it correctly, you should get 3.0 kilowatt hours. Okay, part B, you are asked to calculate the cost of electricity. Okay, so cost of electricity quite straightforward. Take energy, okay, energy from the first part here, multiply by the cost of the electricity, which is 0.27 here per kilowatt hour. Okay, so if you do it correctly, your answer should be 81 cents. Okay, take note, when you have dollar signs, you should have only 2 decimal places as your answer. So sometimes when you do a calculation, you get more than 2 decimal places for your dollars. You have to round off. Okay, that's for question 11. Okay, and that's the end of this paper. Okay, so thank you everyone.